Breault's engineering services works to customer requirements, whether it's simple designs, analysis, straight line analysis. The uniqueness about this project was we went from a design to delivering hardware, which is extremely exciting for an engineer, for the company, and for me individually to be able to deliver functioning hardware that worked for the customer. Breault Engineering was the prime on this project. We brought together the technical expertise. We brought optical engineers to develop the imaging system for both the viewer and the detectors inside the night meter. The electrical team to both design the electrical firmware and the circuit boards that were required to do data processing. And finally, we brought the mechanical engineering expertise, which packaged the electronics and the optics in a housing that was environmentally robust for the environment it was going to be used in. At our kickoff meeting, our customer explained that many lights are too bright or too intense and inherently unsafe to be used at night. So this device would actually be used by municipalities to measure night lights in stadiums or parks, even neighborhoods and residential areas, to determine if the lights meet the specification or requirement that's currently under review in the international community. We used a typical engineering process. We had a requirements phase where we used specifications from our customer and then developed requirements, both us and our subsystem partners.
So it was a good experience working with Breault. Their engineering processes are similar to Breault's in that high-level requirements from the customer are reviewed, and we derive our low-level design requirements from those. And those are traced all the way through test and validation and provide a high level of design assurance to our customers.
We conveyed our concepts to Breault after we had produced a rough prototype, and then Breault took over for the development of the internal details of the instrument, the packaging, and all of the multitude of things that need to go into an instrument to make it a commercial success.
From the requirements phase, we went into a preliminary design phase where the electronic provider was doing circuit board designs and laying out the dimensions for the electronics.
Ridgetop's role was to provide design services for the night meter electronics and software. The electronics was comprised of and integrated a number of subsystems, including a laser rangefinder, a serial display, analog to digital converter, and a photometer. Those subsystems were integrated using a microcontroller, and Ridgetop also wrote the firmware for the microcontroller.
After the preliminary design, we went to critical design phase and did the final design of the housing. Then we went and built hardware, brought them together, assembled here, developing work instructions, test plans, and then we went to a certified lab to test the night meters using calibrated sources to ensure that we did meet our requirements and customer specifications. There's follow-on potential with enhancements, features, evolutions of the product, and also production manufacturing as this evolves and permeates into the marketplace. All these things are very exciting work to do, and we greatly enjoyed working on this project for our customer.